And we'll do that. All right. So looking at science. So one thing real quick, because this happened to me when I first logged in. We are finished with concept 1.1 and we are on to concept 1.2. So when yours opens up, if it doesn't have changes to matter up here, if it's still on describing matter in words and numbers, you might need to switch over to 1.2, which is changes to matter. I did assign this to you in Otis, so hopefully it will show up correctly. But just in case it doesn't, keep that in mind that you need to make sure that you're on 1.2. We are in Wonder today, the very beginning, and we are looking at activity 1 to start with. And activity 1 is just asking you guys a pretty basic question to answer. It wants to know what happens to the mass of a substance when it is heated, cooled, or mixed with other substances. So my first question is, what is mass? Can somebody unmute themselves and share with us what is mass?
Mass is
weight.
Something weight.
Yep. I heard a couple of things
that has weight to it.
Mass is the weight of something. You got it. It's how much it weighs. So what happens to that weight to something that's heated? Anybody just want to share out loud? What do you think happens when it's heated?
It stays the same.
It stays
melts.
Well, is melting the mass?
No.
No. So remember, this is asking what happens to the mass. So when you heat something, the mass stays the same. What about if you cool something? What happens to the mass?
It will stay the same.
It stays the same.
It stays the same. You got it. What if you mix it with another substance? What happens to the mass?
It will either make it heavier.
It will get either heavier or lighter.
It's going to get heavier because now you're taking two things and you're combining them. So you're adding two different masses together. Good. So when you answer this question, make sure you address all three of those things. What happens to the mass when it's heated? What happens to the mass when it's cooled? And what happens to the mass when you mix it with others? Okay, the real meat of this, though, is on to activity 2. So let's take a look at activity 2. Activity 2 has a little video for us. We're going to watch an ice cube melting. Well, we're going to watch the video.
Oh, my funny.
Hey, Science Alliance, the situation is really heating up around here. It's a disaster. It's almost time for the party, and the bowl of ice we had just pulled out of the freezer is full of water. You discover that Aunt Jenna was heating up water for her afternoon tea, and that Uncle Julius had just served up his famous pineapple ice pops and had pulled ice out for the juice. The ice pops remain frozen, but the ice in the bowl turned to water in just a few minutes. Discovery Science Alliance. What happened to the ice?
Ice that disappears too quickly? Now that's a problem. We'll need to collect some data and examine the facts. How will the facts fit together to solve the problem?
Discovery Science Alliance, today's mission. What causes ice to melt quickly? Let's investigate more about melting to find out what happened to the ice before the party starts. Safety stop. Always get an adult's help before you investigate heat.
But what happened to the ice?
It melted.
It melted. Nobody wants to drink warm juice. So look over here. I had my boiling pot of tea. It's so hot, it has steam coming out. And I had my metal bowl with drinks in it.
Ice is solid, frozen water. As soon as you add warmth, it starts to melt slowly from a solid into liquid water. But when frozen things are placed near something hot, like a stove or a hot kettle, they melt faster. At room temperature, frozen things like the pineapple ice pops melt slower. Let's create the scene. There's the hot kettle, and there's the metal bowl of ice. What can you observe about these objects? Nice job. You probably noticed the ice was in a metal bowl. Ice melts at different speeds on different surfaces. Let's do an experiment to see how long it takes ice to melt on metal versus plastic surfaces. Which ice cube do you predict will melt fastest? Why do you think that?
What do you guys think is going to melt faster on
The metal.
The metal.
why?
The metal,
metal
because
goes-
coolers.
Will get hot.
The metal because coolers are made out of plastic.
Oh, okay. So you're comparing something else that you know?
Metal radiates heat and has pretty much like it'll store the heat more because it'll like
I lost the end of your statement there.
Me too.
Diesel, you want to share?
Yeah.
Go for it, buddy.
So I think the metal, because when metal is exposed to heat, and it will absorb the heat and contain it. Obviously, so the air around it will make the metal the same heat, like amount of heat.
All right, let's keep
Like,
watching. What happens?
Like the reason I say it absorbs it, for an example, it absorbs it. Like if you were to wear black clothes,
Uh-huh.
on a hot day you would be hot. But if you were all white, it wouldn't be as hot because white reflects it.
All right.
The black
that-
absorbs it, and when black absorbs it, it makes the air around it warmer
Sounds good.
than it already was.
Here we go.
This. Look, the ice cube on the metal is already turning into a puddle of water. The ice cube on the plastic cutting board is only just starting to melt.
What kind of bowl should I use for my ice next time?
That kind of bowl.
Plastic.
But
Okay.
put more ice in this.
Have you ever heard the word insulating? So it's keeping the cold in the bowl, not bringing the heat in.
Wow! Let's record what we know in our Discovery Science Alliance lab notebooks. We saw that Aunt Jenna was heating up water. Uncle Julius had just pulled pineapple ice pops out of the freezer along with some ice to keep juice cool. But the ice turned into water in just a few minutes. We recreated the scene and made observations about the position of the bowl and what it was made of. We also saw that different surfaces cause ice to melt at different speeds. You've got the evidence. What do you think? What made the ice melt so quickly? Why do you think this?
We are.
Can I respond to his question? The bowl of ice was near a warm stove.
The ice was in a metal bowl.
That's right. Two things caused the ice to melt so quickly. The bowl was metal, and it was near a hot kettle. Now we're cooking with fire or heat. Wonder what you'll discover as you investigate melting.
Awesome. All right, Amaya, I see your hand is up.
So I feel like plastic is the reason why it's, well, I don't know really why the reason is why it's really,
So it's more insulated, like they said. Plastic is more insulated. It has the thicker layer and it doesn't let the heat come in, like how the metal itself will heat up and that heat will transfer to the inside of it.
is that why plastic is always built with ice chests?
Yep. One of the reasons why we don't have metal ice chests, you bet. All right. So then down below, you need to think about melting an ice cube and think about 3 wonder questions. So it could be something like, I wonder what would melt an ice cube the fastest, or what would melt an ice cube the slowest, or, whatever you want. But you need to come up with 3 I wonder questions for down below. Okay, let's take a minute and take out our planners. Do.